everyone. How are you guys doing? Good, good. All right. Hi. My talk today is about sustainable computing and observability. It's very similar to what Mark talked over there, except going one layer little deeper into the software components. Little intro about me. I'm Kunal Nawale. I'm founder, CEO of SigLens. I hail from beautiful state of New Hampshire. SigLens is a open source observability solution. It's 90% cheaper than Splunk, Elastic Search, New Relic. So if you want to reduce your cost by 90%, we help you do that, and that's because of our very efficiently built database. So you've seen this metric over there as well when Mark presented that data centers contribute 2% of world's energy. This number is supposed to grow to 12% by 2040. Increase in energy consumptions leads to increase in greenhouse gas emissions. So pretty much by 2040, 12% of the global carbon emissions can be attributed back to data centers using electricity, heat, and everything else. So what is observability's contributions to this 2% emissions that we have? So observability contributes up to 30% of your cloud infrastructure spend. So companies that are much mature, they spend up to 30% of their cloud budget on observability. In many instances, sometimes they see that the number of machines that they need to run observability, like Splunk or Elastic, is almost the same number of machines as their core app because they're producing too many logs, too much metrics that they need to debug their solution. It's the second highest expense after your infrastructure spend. So why observability, or why do you even need to do this, right? So observability helps you reduce your downtimes. How many of you are not familiar with observability over here? Okay, 2. All right, 3. So quick 30-second about observability. Observability is a thing which helps you look deeper inside your infrastructure. So if you have 100 machines running 20 containers each, then you have a global view of how you can look inside those infrastructure components and figure out what machine is up, what is down. So that's like the infrastructure level observability. We also have application level observability, meaning how many users are logged in your service, what is their experience, which service is the slowest, how do you debug that service. All of those things are provided by observability. In the old days, it used to be called monitoring. Monitoring was just monitoring, but observability helps you observe actually what's going on inside your software, inside your hardware. So it has become a very, very critical component when you're running on more than one machine, right? And especially so when you're running in cloud, since in cloud, machines go up and down, containers get restarted. In those cases, your application can go down and up or have slower response times. So observability is needed over there. So benefits of observability is it helps you reduce your downtimes. So if something is down, you'll get to know it quicker by looking at 1 or 2 screens. And then you can go debug and find out what system or what machine has gone down, and you can debug it. It helps you detect slow performance. If some microservices or some services are running slow, you can detect that. It helps you find some dissatisfied users. So your service is up, but some user somewhere goes to bankofamerica.com and he or she experiences slowness. That's not detectable through monitoring, but with observability, you can find that specific user and see what experience that they have. It also helps you detect unmonitored security issues. Hence, OLI or observability is very important in your network. So how does an observability pipeline generally look like? So it's a very high-level view. You will see over here on your left-hand side, you have your containers, your machines, your VMs, and then you have various agents sitting over there like Fluentd, Logstash, Vector, OpenTelemetry that are collecting this data about logs, metrics, and traces. That data is then pushed through a pipeline like Kafka or Kinesis or Red Panda. And from there on, via a router, it gets stored in one of these observability backends like Splunk, New Relic, SigLens, Datadog, and so on. So this is like a very high-level overview of how observability looks like. So what are the solved problems in this observability space, or where are the optimizations done so that you have reduced your emissions, carbon emissions, right? One is in that collectors phase where you saw on the left-hand side, we have created a lot of good optimizations. The industry has created a lot of good optimizations there to run efficient collectors so that they use less than 1% of the actual compute on those machines. The data pipelines have been optimized, so technologies like Kafka, Red Panda, they have done really good job on efficient computing and storage. So that's also a good solved problem. What are the unsolved problems in this space, or semi-solved problems? Data storage and querying. So a lot of data gets generated, all these logs and metrics, and they get stored. And there are still unsolved things in that area, and I'm going to talk about those unsolved problems and how they contribute, as well as I'll give you some possible solutions over there. So let's walk through some of the solutions. So first solution I would talk about is reducing your log volume, which is everyone is kind of doing that. So how do you do that? You can implement deduplication of event logs. So only store one copy of those things, so your pipelines can do that. On the collector side, filter the logs, do regex matching, do deduplication, do tail-based sampling. These are some of the things that you can do at the front before it reaches the destination. So your log volume, your observability volume is really low. So what are the pros of reducing this by using this approach? It's an easy win. This is the first thing that you could do. It can give you 30 to 50% reductions in your storage and querying infrastructure on your first pass, right? So this is an immediate benefit that you can see right away. What are the cons of this approach? The implementation cost. So you gotta take your developers out from their day-to-day job and ask them to go, hey, go remove this log line, reduce this, change this sampling, and so on. Unfortunately, the organic growth of your company, of your core software, will erase all the gains that you have done. So 6 months, 1 year down the line, you will probably be back at the same volume that you were previously, if you're growing or you're adding more log lines, right? So it's a constant effort that you have to keep doing. Solution 2 is tiering or data storage tiers, right? So what does tiering do is you separate out the data that is coming inside your backends into various tiers. So first is the hot tier, where you store past 1 hour, 2 hours, up to 4 hours of data in these systems. Second is warm tiers, where you store past 7 days of data, which is not that used. And then a really cold tier, where everything else goes, which is not queried 99% of the time. So for hot data, what do? You take this past 4 hour data, you store in this expensive systems like Splunk, Elastic, Datadog. So less data gets stored, and you reduce the cost over there, or your infrastructure over there. Warm data you store in object store systems like GCS, S3, or whatever blob store that you have. And you do an on-demand hydration. So if something goes down and you want to see past 5 day of data, then you go and run some job. It will pull on demand this data from your object store, and it will hydrate your live system. And this happens maybe 1 to 2% of your time when you want to go and look back at older data. So most of the time you wouldn't be needing this. And cold data is you compress it and you store it in a really cold system like Glacier, where you never have to touch this. So more than 7 days or more than 14 days of data can go and get stored there. 99.9% of the time you'll never touch this, right? So then you have a slow batch-based hydration system over here. So basically someone says, oh, I want to look at 1 month old data. Then you submit a ticket request, and then a batch job gets created. It pulls down from that cold storage layer into your warm, into your hot, and then you start looking at the data. What are the pros of tiering, right? So another immediate cost reduction. You can see a immediate cost benefit over there. The cons are implementation cost, slow hydration, and increased downtime. So solution 3 is efficient databases. So efficient databases, you can use systems like this, Scalar, SigLens, which are really optimized for this kind of data volumes. So the pros of efficient databases is you get an immediate cost reduction, no on-demand hydration, so the data that is 1 minute old versus 1 day old versus 1 month old gets the same treatment, because these databases are built in a really efficient way where they treat everything equal and there is no delay on doing on-demand things. By doing this, you have reduced downtime, and there is zero implementation cost. So it's just like replacing a Splunk Elastic Search cluster with this efficient databases. The cons are it's a relatively new technology. This is something that has emerged in the past 3 to 5 years, but it's gaining a lot of ground, and it's helping you reduce your infrastructure footprint by more than 80–90%. Right? So just one quick example about our benchmark. We did a 1 petabyte test. We ingested over a petabyte of data in 24 hours. We needed only 32 machines, right? For the same volume, you would need 3,000 machines of Elasticsearch, right? So that's the huge difference that this kind of databases provide. Our cloud cost was just $1,200 for that day versus $100,000 you would need for that 24-hour period to run the same test with Splunk or Elastic. And this is a screenshot of our usage of this thing. It's 1,200. There's a blog about that. We wrote about it publicly, so go check out that blog. And yeah, so SigLens is an open source repo. Go try it out and for yourself. And thank you for having me. Any questions? We also have a booth over here, so stop by. Feel free to ask any questions you have after the call. Thank you.